Hello everyone. This is my internship presentation for embedded systems conducted by Ematech. My name is Sai Kishore and in this video I will explain what I learned and implemented during this internship. This internship was completed at Ematech, a reputed institution for embedded systems training. It focused on embedded systems with strong practical exposure. During this internship, I gained hands-on experience in C programming, embedded programming concepts, microcontrollers, and hardware interfacing. I also worked with embedded tools and successfully implemented a real-time project which helped me understand the complete project development process. The main goals of this internship were to gain hands on embedded experience, learn microcontroller programming, understand simulation based development, and improve debugging skills. For C programming, we used Dev C++. For project implementation, we used MPLab X IDE software, XC8 compiler, and PiximLab simulator. They also explained installation and each steps set up clearly. During my internship, we began by learning the fundamentals of C programming. Initially, we studied basic data types such as int, character, float, and double, along with type modifiers like sign, unsigned, short, and long to understand memory usage and data range. We then explored various operators including arithmetic, relational, logical, assignment, bitwise, and ternary operators. Conditional statements such as if, else, and switch were explained in detail, along with control statements like break and continue. Arrays were introduced to store multiple values efficiently, and the size of operator was used to understand memory allocation. We also learned string handling using standard library functions, which helped us work with character data effectively. Functions were an important part of our learning, where we studied pass by value and pass by reference, recursion, and how arrays can be passed to and returned from functions. All these concepts were implemented practically using Dev C++. In addition to the core concepts, we learn advanced topics related to memory and program structure. Pointers were explained in depth, including pointer basics, NDNS, and special pointer types such as null pointers and wild pointers. The constant qualifier was also discussed. Understand data protection in programs. We study storage classes like auto, static, extern, and register to understand variable scope, lifetime, and memory location. Preprocessor directives such as macros, ifdef, and ifndef were introduced, which are used for conditional compilation and code optimization. These topics helped us gain a clear understanding how C programs are compiled and executed at a low level. Embedded systems combine hardware and software to perform specific tasks. They are widely used in household and industrial devices. We studied microcontroller architecture including CPU, memory, input output ports, timers, and interrupts. We implemented interfacing programs for LED switches, matrix keypad, and character LCD display. Polling and interrupt mechanisms were explained. Timer modules were used to generate delays and counters. My project is a microwave oven simulation. It controls different cooking operations using a microcontroller. I developed this microwave oven project using PIC16F877A microcontroller in PiximLab simulator. It includes user interface, timer control, and temperature control. The project requires PiximLab simulator, PIC16F877A microcontroller, LEDs, switches, and keypad, and MPLab X IDE with XC8 compiler. This microwave project supports different cooking modes: normal heating for regular cooking, grill mode for crispy food, convection mode for baking, and quick start for instant heating. User selects cooking mode, sets the time, starts operation, and the system performs heating. After completion, it stops automatically. The project was implemented by writing code, integrating modules, debugging, and testing in simulator. Now I will demonstrate the project using PiximLab. I have loaded my compiled X file into the microcontroller and I reset this microwave oven. You can see the 4 cooking modes. We start with normal heating mode and we set time using the keypad and the enter time is displayed on the LED screen. Now I press the start key. The system begins heating operation and when we pause it stops and we resume it continues, and again we can pause or you can stop this. Here we continue again and we stop now. Again if we choose another mode, grill mode, again we set the time for this mode. The time is displayed on the LED screen. I have entered the time and now I press the start key. The system begins heating operation. Now again we choose convention mode. In this mode we set temperature and again we start this. You can see now the time remaining there on the LED screen. After the time completes, the system begins heating operation. Let's wait until the time completes. Now again we enter the time now. We have set the time for 1 minute. We see that system begins heating and now we stop this and using the start mode it automatically starts the mode. With this I conclude that my microwave oven project is working. This internship helped me gain strong knowledge in embedded systems and microcontroller programming. In future, this project can be implemented on real hardware and enhanced with more features. Thank you for watching my presentation.